Today we are going to continue with our work in Chapter 6, in Section 6.1, continuing talking about the law of signs. Yesterday we did items 1, 3, and 4 on this list. Today we're just going to focus on number 2, which is using the law of signs in the ambiguous case. So just a reminder that here is what the law of signs looks like. And yesterday we worked with the law of signs in these two cases, when you knew angle side angle or angle angle side. Well, something actually interesting happens when you have side side angle. And if you remember back to your geometry days, you might remember that this was not a valid way to prove triangles congruent. Because if you look at this, if you've got this side, the side of this angle, if you take this side here and swing it around, you can actually make a second triangle that also has that exact same side, and angle. And that's why we call it the ambiguous case, because that means ambiguous means the unclear or not certain case. So when you have side angle, there might be two different triangles that it could be. In fact, there's a lot of different things that could happen when you know side angle. For example, if I gave you this angle, this side, and this side, well, this side isn't even long enough to reach this side. So in this case, there's no triangles that could be made. In this case here, I've got this angle, this side, and this side is just long enough to reach that side. And if you swing it around, there's no other triangles that could be made, so there's just this one triangle that could be made, and in this case, this happens to be a right angle there. Here's the case that I was just talking about, that if you take this side and swing it over here, you can make a second triangle. But in this case, if this side is longer than this one, you can actually swing this around and not make another triangle. So here's another case where there's only one triangle that can be made. All of these examples here are if the angle that is given is acute. If the angle given is obtuse, then it looks a little different. Here, the side isn't long enough to reach, so you can't make any triangles. And here, if it is long enough to reach and you try swinging it around, you cannot make another one, so you can just make one triangle. So you can see there's a lot of things that can happen here. Here's one triangle that could be made. Here's one triangle. Here's one triangle. Here's no possible triangle. Here's two possible triangles. And here's no possible triangles. Now, there are rules about when you're in each of these cases that have to do with comparing the height of the triangle to the side lengths, or whether or not this angle is acute or obtuse. But instead of trying to memorize all those rules to decide which of these 6 cases you're in, I find it's easier just to attempt to apply the law of signs and see what happens with the numbers you get. And I'll show you what I mean right here in these next 2 examples. So, determine the number of possible solutions for each triangle. Our first triangle here, angle A is 63 degrees, side length A is 18 degrees, and side length B is 25 units. So I'm going to attempt to draw this triangle. I'm going to start with the sketch, and I've got A, B, C, and give it an angle A is 63 degrees. Side length A is 18 units, and side length B is 25 units. And now what I'm going to do is I'm just going to set up the law of signs. Keep in mind that there might be 0, 1, or 2 triangles that this can be. What I set up the law of signs is side length A, 18 over sine of angle A, which is 63 degrees. I'm going to use that fraction because I know both the numbers in that fraction. And I'm going to set it equal to side length B, 25 over sine of angle B. And now you can see I've got an equation here with one variable, so I can solve it. To solve for B, I need to start by I'm going to cross cross multiply here and get 18 times sine of b equals 25 times sine of 63 degrees, and then you can divide that 18 to get sine b equals 25 times sine of 63 degrees divided by 18. Now that's what the sine of angle B is. I still need to solve for angle B. So what I do next is I take the inverse sine of both sides. That will give me B equals inverse sine of, and all this will just stay the same. And from here, you can just type that all into my calculator. So, first make sure you calculate in degrees, and inverse sine of 25 times the sine of 63 degrees divided by 18. And the calculator tells me that angle B is, oh no, error. Why did that happen? Let's actually take a look at just this part real quick. You can take a 25 sine of 63 degrees divided by 18. And notice I got about 1.24. So what I'm asking my calculator here to do is inverse sine of 1.24, but do remember that we cannot do inverse sine of numbers bigger than 1 or less than negative 1. So there is no angle that has a sine of 1.24, which means there are no solutions to this triangle. That means this diagram that I drew over here at the beginning is actually a lie. This doesn't even make a triangle. Basically what this means is this side line here is only 18 units long, and that 18 units long isn't enough to reach the side line, so this isn't even a triangle. Take a look at another example. So, if angle A is 105 degrees, we draw this diagram like so. I might actually draw angle A. We'll just scale here. So it's not too simple because it's 105 degrees. And then side 1A is 73, side 1B is 55. So, I'm trying to figure out how many triangles are possible. So I'm going to do the same thing I did and just pull off sides. 73 over sine 105 degrees equals 55 over sine of angle B. To solve this, I'm going to cross multiply and then divide by 73, and I'll get sine of B equals 55 times the sine of 105 degrees divided by 73. Then, to solve for B, I need to do inverse sine of sine. So it's inverse sine of 55 times sine of 105 degrees over 73. And type that in my calculator. Sine of 55 times sine of 105 degrees divided by 73. And I get 46.7 degrees. So how do I know whether this is only one triangle possible or two triangles? Well, it all has to do with this step that I just did right here. When you do the inverse sine of something, there's something you have to remember about the sine function. That is, that sine is positive actually in two different quadrants. Which means in this step right here, there is actually another possible answer. This 46.7 degrees is just my first quadrant answer. And remember that your calculator only gives you one answer when you do inverse straight functions. So there is actually another answer to this inverse sign, and that would be the quadrant 2 angle that has a reference angle of 46.7 degrees. So it's going to be 46.7 degrees less than 180. So to find that other angle, I'm just going to do 180 minus 46.7. And my angle is 133.3 degrees. So this step right here actually has two different answers, and calculator will only tell you one of them. You need to make sure you are thinking about and finding the other one. However, you might have noticed this new angle right here is 133.3 causes a problem. Because if I actually try to put that angle into my original triangle, you'll notice I already added a acute angle in this triangle. And if I add together these two angles, 105 and 133.3, I'm actually way over 180 degrees. So that actually tells me that this second possibility doesn't actually work to make a triangle. Which means this 46.7 degree angle is now the only possibility I have left for angle B, which means this triangle has one solution. Go ahead and take a look at the next couple of examples, and I'll show you actually how to continue solving the triangle in all these cases, and we'll even look at some cases where there are actually two possible triangles.